Before we can calculate molarity, we need to understand some definitions. Molarity itself is defined as moles of solute divided by liters of solution. Remember that a solute is some substance that dissolves in another substance to form a solution. For example, sugar can dissolve in water and form a solution. We still need to understand what a mole is, though. And it isn't this. The definition of a mole is that it is the amount in grams equal to a substance's molecular weight. It just allows us to measure something out in grams, a substance we can deal with, and know what's going on at the molecular level. So to understand that definition, we need to know what the molecular weight is. The molecular weight is just the sum of the number of atoms of a particular element times the atomic weight of that atom. And then you add up all the atoms and atomic weights that are present to get the total weight of the molecule. These definitions may not make a whole lot of sense. Molarity is pretty hard to define, but don't worry. It'll start to become clear as we look at some examples. Since we're going to be looking at atomic weights, we need to use a periodic table. There's a lot of elements here. Fortunately for us, only about 20 of them are important in living organisms. So let's just look at part of our periodic table. So suppose I was asked what the molarity was of 188 grams of magnesium chloride in 4 liters of solution. I work backwards from my definitions. First, I need to figure out my molecular weight. I have 1 magnesium. If I look in my periodic table for its molecular weight, I see that it's 24.31. This is not a math class. We're trying to understand molarity. Let's just ignore that 0.31. In an actual chemistry class, you'd probably need to pay attention to that, but let's just round that to 24. So we have 1 atom of magnesium weighing 24, so our total weight for magnesium is 24. We have 2 atoms of chlorine. Each of those weighs about 35, and again we will round. So the weight of the chlorines is 70. So the weight of our individual atoms is 24 and 70. To get the weight of the whole molecule, I add those 2 together. Adding 70 and 24 gives me 94. So 94 atomic mass units is my molecular weight. If I go back to my definition of mole, it is the amount in grams equal to that molecular weight. So in this case, 94 grams of magnesium chloride would be 1 mole. My question tells me that I have 188 grams. How many moles is that? Well, 94 goes into 188 2 times, so 188 grams would be 2 moles. At this point, we're almost done. We just need to figure out molarity. Remember, our formula for molarity was moles of solute divided by liters of solution. We have calculated that we have 2 moles. Our problem tells us that we have 4 liters. So if we calculate 2 moles divided by 4 liters, we get 1/2 or a 0.5 molar solution. And that 0.5 molar is the answer to this question. So let's try an example to figure out the molarity of 71 grams of Na2SO4 in 2 liters of solution. Just like our last example, first we have to figure out the weight of this molecule by figuring out the weight of each atom in the molecule. Remember, if there's a lowercase letter next to it, it's a single type of atom. In this case, it's sodium. Whereas if we have 2 capital letters next to each other, it's 2 separate atoms, sulfur and oxygen. So we have 3 atoms. We have 2 molecules of sodium. And if we look in our periodic table, each sodium weighs about 23 when we round it up. So the weight of sodium atoms in this molecule are about 46. We have just 1 sulfur. It weighs 32, so it contributes 32 to the mass. Remember, when you're doing these calculations, you're using the weight, the bottom number in this periodic table, not the atomic number. The atomic number is just the protons, but both protons and neutrons give mass. So when we're calculating weight, use the atomic weight. Finally, we have 4 atoms of oxygen. Once I've figured out the weight of each atom, I add them together to get my molecular weight. This tells me that 142 grams is 1 mole, and I have 71 grams. So do the division. Divide 71 by 142. This tells us that we have 1/2 or 0.5 moles. So again, to calculate molarity, we take our moles and divide it by the number of liters, and in this case we would have a 0.25 molar solution. So suppose we wanted to figure out the molarity of 200 grams of CH3Cl in 4 liters of solution. Again, we would start by figuring out our molecular weight. You see how many atoms of each type we have? And look in the table for the bottom number, their weight. Then we add up the weight of the individual atoms. Our molecular weight is 50. 50 grams is 1 mole. We have 200 grams, so we have 4 moles. So to calculate our molarity, we have 4 moles divided by 4 liters. So we have a 1 molar solution. So we just, to calculate molarity, to figure out the molecular weight, compare that to the weight we have, figure out how many moles we have, and then divide the moles by the liters. So even though molarity seems confusing, if you take the steps and go backwards, figure out your molecular weight by adding up the weight of the atoms, use that to figure out how many moles you have, and then use the formula, figuring out molarity really isn't that difficult.